So, as promised, I'm going to look at these two examples and show you how we can calculate, well, in the case of the first example, the standard change of enthalpy for reaction using the values from the tables I just showed you, all right? So what I'm going to do is I'm going to come to, let me see here, I'm going to bring up this particular PowerPoint on another computer so I can have it to refer to while I'm doing the problem. And also use this other laptop to get the table of values. 1 minute here. Okay, the other laptop here is acting up. Okay, I got it working. Okay, good. So basically, I'm going to get out of this here, and I'm going to go to my writing tablet here. Let me get rid of this previous work. Okay, so the equation we're given in this question is 3CH4 gas plus 2H2O gas, I'm sorry, liquid, plus CO2 gas to form 4CO gas plus 8H2 gas. And the question is asking for delta H for each of these, right? Now, as I said before, all we have to do is find the total enthalpy of the products and subtract from that the total sum of the enthalpy of the reactants, right? So basically, I need to refer to the table. So I'm going to find the table here. Okay, I thought I had it here. Oh yes, I have it here. Okay. So the table, so what I'm going to do is look up the enthalpy of formation of each of these substances, starting with the methane. So according to the table here, for methane, which is CH4, and it's a long list, so it really, takes some time for you to find the different substances. So methane is, okay, where is it? Methane, okay, so for methane, the enthalpy of formation is minus 74.81 kilojoules, right? But we have to multiply that by 3 because of the coefficient of 3 here. And then for water, okay, so let me look for water. And also, one thing I should say here, when you're looking up for these values, make sure that the state is, the state of the substance is what you want, right? Because as I'm looking at the table here, there are two different values for H2O in the liquid state and H2O in the gaseous state, right? So it says here liquid state, so that's the one I'm using. H2O liquid, the value is minus 285.83 kilojoules, but we have to multiply that by 2, all right? And then for the carbon dioxide, let me look that up. Carbon dioxide in the gaseous state. Carbon dioxide, where are you? Okay, carbon dioxide minus 393.51. So plus minus 393.51 kilojoules. And then we basically do the same thing for carbon monoxide on the left side. So let me see, carbon monoxide is 4 times minus 110.53 kilojoules, I'm sorry. And then now we get to the hydrogen. And you'll notice that hydrogen is by itself, not combined with anything, and exists as H2 in its standard state. So therefore we know that that value is 0. So 8 times 0, which gives you 0 kilojoules, all right? Okay, and then what we have to do is add all of this up here for the products and all of this down here for the reactants. So let me do my calculator thing. Let me do the products first. So 4 times minus 110.53. Okay, so according to my calculations, the total enthalpy of formation on the right side is minus 442.12 kilojoules. And then on the on the left side, I'm going to multiply minus 74.81 times 3. And then I'm going to add to that 2 times minus 285.83. And then I'm going to add to that minus 393.51. Okay, let me do this again. I think my answer may be wrong. I'm going to redo this calculation. So 74.81 minus times 3 equals that. And then 2 times minus 285.83. Okay, I knew I did something wrong here. And then minus 393.51. Okay, so the answer I got for the left side is minus 1189.60 kilojoules. And then it's a products minus reactants, so it's going to be, for delta H standard, it's going to be equal to minus 442.12 kilojoules minus 1189.60 kilojoules. And that's it. So let's do that now. Okay, so the answer I got here is equal to 747.48 kilojoules. All right. So that's basically how that is done. All right. So it's rather simple, even though I would say that the most challenging part of solving a problem like this is looking up these values, the values for delta H in the table, because the table is very comprehensive, has a lot of data about a lot of substances. So it will take you some time to find the different substances. But once you do that, then it's a matter of basically summing up all the enthalpy values for the products, do the same thing for the reactants, and then set it up such that you have the products minus reactants in terms of the enthalpy change, and that gives you the final answer. All right? Okay, so we're going to stop here for this